Well, we made it through 1.7. We are now into 1.8, which is the applications and the models. There's only going to be a couple of these videos. Not much to it. You've already done all the work. Now we're just kind of putting it together. Putting it all together. So we're just going to solve some triangles in this one. That's kind of the game. So here's kind of some instructions, some stealing stuff that's pretty similar to what you have in your homework. Asks us to solve the triangle and round to 2 decimal places. Okay, well, when we solve, that's saying find all the angles and all the sides. And in trigonometry, all we need is 2 pieces of information. As long as those 2 pieces of information aren't just 2 angles. As long as it's any combination that's not just 2 angles, we can solve the triangle. You give me a side and an angle, I can solve the triangle. You give me 2 sides, you can solve the triangle. You can't do it with 2 angles because we don't know what the lengths of the sides would be. So this is, I don't know, it's going to label it for you in your homework, but I like to go, that's A, this one's B, this one's C. And then opposite angle A, or side A will be angle A, opposite side B will be angle B. And then for some reason your book or your homework calls this one side C, or angle C. I don't know what I think I could probably figure out what that is, you know? Maybe we'll start there. So there it is. We got to find 4 pieces of information. So let's just start listing it down. And it tells us to round to 2 decimal places. So let's just say big C, 90 degrees. Oh yeah, hang out in degrees for a little while, huh? We're going to hang out in degrees for a little while. When we do word problems, things of that manner, applications, we usually talk in degrees. It's, yeah, it's kind of how it can be until you get to your calc. All right, so we got our C. Now, what would you go for? What would you go get? Huh? So C's gone. Let me just get rid of that, actually. I don't know, let's go get, we can get anything we want. We can get A right now. We could get B right now. We could get little a right now. Let's go get little a. Let's just kind of clean it all up. All right. A squared plus, and then what's that? 4 squared is equal to 7 squared. I think you've seen this one before. So I get a squared plus 16 is equal to 49. We subtracted on, no, I don't think I've done this one yet. Oops. Subtracted over, we get a squared is equal to 33. 33, yeah, and we'll hit that thing with the square root. And in these applications, so to trip out about a plus or a minus, that's not going to mean anything. So let's replace it and go, well, this is the square root of 33. Whatever the hell that means. And I'm making a list off on the right-hand side. So cool, we got our sides. But inverse trig is all about solving for those angles. So now we got options all day long. All day long. What do you want to do? What do you like? Do you like sine? Do you like cosine? Do you like tangent? What do you like? Yeah, I'm just going to randomly write something down. Just going to go, let's go sine of B. B. Cool. What is it? Opposite over hypotenuse, right? So 4 over 7. Now here it is. You know the bullshit composite stuff I was making you do? I'm like, you asshole, this is a pain in the ass. Why are we doing this? It's because if you want to get the angle out of the argument of a trig function, you want to get this angle out of the argument of a trig function, you just hit it with its inverse and it just goes poof and it pops right out. Now you don't have to show me this step and I'm doing it, but I'd like you to see it. That if we hit both sides with this little inverse, right? Remember that the inverse of the trig function, oh, you just go right back to where you started. So this is B is equal to sine inverse of 4 over 7. Oh shit, there's the exact answer. But the thing is, this question, it's not asking for the exact answer. It's asking us to round to 2 decimal places. So we go and we take it, we punch it in our calculator, we hit second, then we hit that sign button, and we put 4 divided by 7 on in there. We take it and we round it to 2. So I got 34.849. Round to 2, right? So we'll just call this 34.85. Yeah? And we'll put that little degree symbol on it too to make sure we're badasses. 34.85 degrees. Cool. So there goes that B. I'm going to put it inside. I prefer to put them inside the triangle, but I'm trying to write like you would see in your text. Now, the only thing we're left to go get is A. Now, you want to use... Do you want to go through and hit it with another inverse to solve this thing, or will you just go with the fact that the sum of the interior angles of a two-dimensional triangle is always going to be 180? What? So we're going to say that A is equal to 180 degrees minus the other two frickin' angles, dude. 90 and 34.85. So we subtract it out. And we're like, all right, we punch out, so what's that, 90 minus 34.85, and we get what? That our A is going to be approximately equal to 55.15 degrees. Frick, yeah, we did it. We did it. See, there's nothing to it. There's nothing to it. You got this shit. If you made it through inverses, you're going to be just fine getting through this. There's going to be that one step. There's that 4 pieces of information. There's going to be this one step that to have to set it up that's wonky. But remember, inverses are angles. Therefore, an angle, you must be hitting it like a sine inverse, a cosine inverse, a tangent inverse, something of that matter. Don't hit it with a cosecant inverse. And if you do, tell me how you did it. So there's your solution to this. Let's go up to another. And I'm not actually going to finish this one. I just want you to see. Maybe I'll finish it. I don't know. We'll see. I don't really plan before I go too much. So for this one, all we're given is a side and an angle. So then I would ask, if we were in class, I would look at one of your students and I'd be like, all right, cosine or tangent? Doesn't matter. Just pick one. Why would I say cosine or tangent? Because the only angle that's given to us, the only piece of information we know about a side is its adjacent side. Sine doesn't talk about the adjacent, but cosine is the adjacent over the hypotenuse, and tangent's the opposite over the adjacent. So for this one, you know what? I'm going to think tangent, because that could help us solve for the opposite. Let's go. We got an angle. Let's go get B. So we can just start by saying, all right, let's just go. Tangent of 24.4 degrees is equal to our opposite, which is B, that B that's right there, over the adjacent, 1.1. Well, let's just multiply the 1.1 over to the other side. Is equal to B. Well, let's punch that in. 1.1 times tangent of 24.4 degrees. Hey, y'all, change your calculator. If you've been hanging out in radians, change your freaking calculator. Did you hear me? Change your freaking calculator. You do it. You change your calculator. You put it in degrees. It just sucks to get the wrong answer when you're doing all the right work. It's frustrating. So this becomes 0.498. You write down 3 when you want to round to 2. So you're like, oh, that's got to get bigger, making this approximately 0.5. How convenient. I had no idea that was going to happen. I was just randomly writing down numbers. I didn't know it was going to turn out clean. Turns out to be a half. Yeah, duder. There we go. So we can call it a half. You don't have to write the 0. I just have a habit from my teacher in statistics that told us to round to 2 decimal places, and I had something that was exact and went to here, and he went, no, wrong, and he took all my points from me because I did not follow directions and write down the 0 at the end. Ooh. Math teachers, we can be assholes. Assholes. You'll have that moment with me. Don't worry. You'll have that moment where you're like, what a jerk. I did this, and it happens. All right, let's go solve for C. C, the other side. So C squared is equal to 0.5. No, I'll write like that. 1.1 squared. Remember, we're rounding, so C is equal to the square root of 0.5 squared plus 1.1 squared. We punch that into a calculator. No biggie. Make sure you use more parentheses than less whenever you do anything with a calculator because your fingers are going to get fat. I have little dainty fingers, but man, when I use a calculator, they feel like they're gigantic. So I get approximately 1.21. 1.21. Oh, and by the way, nothing I draw is to scale. I just make a right triangle. And then now, let's go get angle A. Let's go get angle A, huh? We can go get it. And how do you want to solve for it? Maybe the fact that we already know that C is equal to 90 degrees. So we just do. Let's get A. There it is, and we'll be done. A is equal to 180 degrees minus that 90 degrees minus that 24.4 degrees, which will give us, what's 90 minus 24.4? What is 90 minus 24.4? And we get 65.6 as our answer. 65.6. So there we be. Solved out. 4 angles. It's the same game, pretty much over and over. 5.6. But be good with this game because we're going to do this in chapter 3 with any triangle, not just with right triangles. So getting this practice now will make that stuff even simpler when we get to it. So, all right, I'll see you in the next with some applications.